Hello, in this video I'm going to give you directions on how to do the math connection for calculating albedo. So let's get started on that. This is what the assignment looks like in your weekly work. And so we're going to start off with the video, and on the video you will be answering these questions about albedo, which is just how much light is reflected from the Earth. Then after the video I will show you how to calculate albedo for different surfaces. So let's start the video right now.
In order to understand the Earth's climate, it's critical we understand how warm the planet is, how its temperature changes over time, and what factors can force those changes. The sun is the Earth's primary source of heat, constantly bathing us with solar radiation. The land surface, cloud cover, and our atmosphere help determine how much of that heat is reflected and how much is retained.
How that changes over time is really critical, because in a climate system that's in equilibrium, those two should really balance, and if they do, then the temperatures will remain relatively constant with time. Now, when you add greenhouse gases such as carbon dioxide, methane, you change that radiation balance at the top of the atmosphere. You reduce the amount of outgoing radiation, and so that imbalance means more energy is in the system. Part of it goes into the ocean, is stored in the ocean, and part of it goes into actually warming the Earth.
One of NASA's most important tools for measuring that heat is an instrument on board the Aqua, Terra, TRIM, and NPP satellites called CERES, Clouds and the Earth's Radiant Energy System.
CERES instrument has exactly 3 channels, but those 3 channels have been tuned to get really important information about long-wave radiation from the Earth system, the reflected short-wave radiation from the sun, and then a window channel of radiation. So it's got 3 channels that give us a huge amount of information about the radiation budget of the Earth.
CERES observations complement data from another instrument on Aqua and Terra called MODIS. MODIS has a smaller footprint, but much higher resolution to its data, illuminating how the energy budget is affected by clouds, dust particles, oceans, and land cover. That energy budget can also be influenced by natural events, such as the La Nina and El Nino weather patterns, the amount of ice and snow covering the Earth, and events that impact the Earth's atmosphere, like volcanoes. Researchers use CERES data and similar data sets from the past to establish a long-term trend that encompasses all those factors and the natural variation of the Earth's radiation budget.
If you want to look at changes in the system that are significant, that might be associated with actual global warming, you have to measure above that natural variability. So you need a long record.
The CERES instruments and their predecessors have been taking the Earth's temperature for almost 30 years, and this data can be used in conjunction with other measurements of the Earth's vital signs.
And so having the CERES measurements, the ocean heat storage measurements, measurements of sea level rise, measurements of land ice volume, all of those should give you a coherent picture of how things are changing as we warm the climate.
Now it's time to calculate some albedo, so let's do some problems. So calculating albedo. Alright, so this is the chart that you have on your activity, different color. So what we have black asphalt, and black asphalt has 100 units of solar radiation coming in, and 4 units are reflected, so the albedo for that is going to be just a simple problem where we take our reflected light 40 or 4 units, and we would divide that by our incoming light, which is 100 units. And if we do that, you'll see that you're actually just moving this decimal place 2 to the left, 1, 2. All right, and that will give you 0.4. So 1, 2, 0.4. All right, and then if we're doing percent, we're actually moving it exactly back to the same place because we're multiplying by 100. And so that would end up being 4%. So yes, the albedo is going to be, the percent albedo is going to probably be equal to the exact same number here, and the incoming is going to be moving the decimal place 2 over to the left. Let's do another one. So black asphalt has a fair amount of albedo, about 4% of the light is reflected. So for open ocean, we have 6%. So again, we take our reflected light and we divide that by the amount of incoming radiation, and that is going to equal 0.06 because we move it over twice, 1, 2, and that is going to be equal to 6% albedo, or which is the open ocean. So in going back to our activity, you'll answer the different albedos for these things and see which one has the biggest albedo. Then we'll look at 2 planets that have albedos besides Earth, and then you'll answer this question about which planet, a water planet or an ice planet, would have the highest albedo and your reasoning behind it. If you have any further questions, please see your science teacher. Have a nice day.